Welcome to Calculus. Today we will investigate finding the average value of a function, looking at some polynomial and rational function examples. We'll take a look at 3 examples. Our first question here, we want to find the average value of this function over the given interval using the mean value theorem for integrals. And another name for that theorem is the average value of a function on an interval. We're going to consider this function. It's a quadratic, 2x squared plus 4x over the interval from -3 to 1. Well, let's state the average value of a function on an interval. What that says is that if I have a function f that is continuous, in fact, let's change that. If f is integrable on the closed interval from a to b, then what we would call the average value of the function on the interval is going to be given by this formula. 1 over the difference of b minus a times the integral from a to b of f of x dx. And what we're claiming is that is the average value of the function. Well, let's apply this result here to this example with this quadratic. So if I'm looking for the average value of f of x here, we can set it up according to this definition of average value of a function. So for this one, it's going to be 1 over, so my a and b are given by -3 and 1. So it's 1 over the difference of b minus a, 1 minus -3, times the integration from -3 to 1. And I'll put as my integrand the function 2x squared plus 4x dx. And that's ready for us to calculate. The fraction out front is going to be reduced down to 1 over 1 plus 3, which is 4, so a quarter. And then we'll integrate this 2x squared plus 4x. So that's going to be 2. We're looking for the antiderivative of x squared, so that's going to be 1/3 x cubed. And then for my second term, to integrate 4x, we're going to put that constant coefficient 4, and then the antiderivative of the linear parent x is going to be half times x squared. And again, we're going to evaluate that from the value of -3 up to 1. So we're ready to substitute in our limits of integration and simplify. So that's going to be a quarter. I can combine these multipliers. 2 times 1/3 is 2/3. And then I'm going to start plugging in my upper limit of integration. So 1 cubed. I can combine 4 and a half. 4 times half is just 2 times 1 squared. And we'll put some brackets around that and then subtract from it the same expression, but with the lower limit of integration substituted in. So this is now going to be 2/3 times -3 to the power of 3 plus 2 times -3 to the power of 2. And that's ready for us to now evaluate. We're down to just numbers. We just need to simplify. So now what I've got is 1/4. So I see here this is going to reduce to 2/3. Here 2 times 1 squared is just 2. So I'm going to call 2 6 over 3 so I can add it up there. So that's going to be 2/3 plus 6/3. This integration with the upper limit subbed in is going to have a value of 8/3. Put the minus. Let's evaluate the blue expression. So negative 3 cubed is going to be negative 27. And if I divide that by this 3 in the denominator of 2/3, that's going to be negative 9. Times 2 is negative 18. And then 2 times negative 3 squared, that's going to be positive 9 times 2 plus 18. So those cancel out. So really what I'm left with is 1/4 times 8/3. But then again, 8 divided by 4 is 2. So our final average value of this function is 2/3, 2/3. Let's take a look at a second example that involves a fractional power, 4x to the power of half. So I want to again remember my formula for the average value of the function. It's 1/b minus a times the integration from a to b of f of x dx. So here my a is 0, my b value is 3. So we'll set up the average value. And that's going to equal 1/3 minus 0. So that's going to reduce to 1/3 times the integration from 0 to 3 of my function 4x to the power of half dx. Now we're ready to integrate. So that's 1/3 times constant 4. And then to integrate x to the power of half, I'm going to think that's got the antiderivative of x. If I added 1 to that power, it'd be 3/2, but then I've got to multiply times the reciprocal of that power, so 2/3 out front. So the derivative of 2/3 x to the power of 3/2 is going to be x to the power of 1/2. We'll include that here, so I'm going to put 2/3 times x to the power of 3/2, and we'll integrate that again from 0 to 3. So now we're ready to substitute in my limits of integration. So that's going to be 1/3 times, I can reduce this 4 times 2/3 to 8/3. So 8/3 times the upper limit of integration, 3 to the power of 3/2. And then I'm going to subtract from that 8/3. And I'll substitute in the lower limit of integration, so 0 to the power of 3/2. But that whole term in blue there is going to cancel because of the multiplier 0. So what we've got now is going to be 1/3 times 8/3. And then 3 to the power of 3/2, I can cube it first. So 3 cubed is 27. And then the denominator 2 is a square root, so it's the square root of 27. But I can withdraw by factoring a 9 out of the 27. So the 9 will exit the square root as a 3. So it's going to become 1/3 times 8/3 times 3 times the square root of 3. And then I see my 1/3 and my 3 would cancel out. And so what we're left with is 8 times the square root of 3 over 3. And if I were to give a decimal approximation, that has about the value of 4.619. So those two examples were polynomials. Let's take one last look at a rational function. So here we've got f of x equals 4/x squared. And I want to find the average value of this function over the interval from -3 to -1. Remember the average value definition again is 1/b minus a times the integration from a to b of f of x dx. So for this example, my a is going to be -3, my b is going to be -1. So I'm going to set up the average value equals 1 divided by the upper limit, -1, minus the lower limit, -3, times the integral from the lower limit, -3 to -1 of 4 over x squared dx. Just like with the other examples, I want to start off by simplifying my average function, or my average fraction out here in front. So it's 1 over -1 plus 3, which is going to be 1/2. And then I want to find the antiderivative for this 4 over x squared. So if that was my derivative, the antiderivative will have the 4. And then remember that power of 2 in the denominator is equivalent to the power of -2 in the numerator. So if I'm thinking antiderivative, this is going to have the power of -1, and that -1 is going to be included as a multiplier out front. So my antiderivative is going to be -4 over x. So we'll take the derivative, so -4 over x. Got some extra parentheses there, clean them up, and we'll evaluate from -3 to -1. So we're ready to substitute in our limits of integration. So this will be 1/2 times -4 over -1 minus -4 over -3. So we just need to reduce and simplify here. So this is going to be 1/2 times 4 minus 4/3. And that I need to combine my fractions. So 4 itself is equivalent to 12/3, which now I can combine with 4/3 by subtraction. That's going to be 1/2 times 8 over 3, but then again, 8 divided by 2 is 4. The average value of this function from -3 to -1 is 4/3. Thank you for joining for this investigation of finding the average value of a function on a closed interval using the mean value theorem for integration. See you soon.